All right, so here we are, series and parallel circuits. We talked a little bit about this the other day, but we didn't really focus too much on it, so we're going to learn about it here today. Got a pencil? Okay. Series and parallel circuits. So we talked about circuits. We actually did a little bit of work on this assignment. We're going to finish the instruction, and then you guys can finish this assignment. But when we talk about series, and we mentioned this the other day, that all the things are kind of like in a row, right? And they're in a big kind of circle. That's called series, and we're going to talk a little bit more about all that here today. So, circuits consisting of just one source and one load are very simple to analyze. So if we have one source, like a battery, and one load, like a little lamp, little light bulb, they're really easy to analyze, but they're also not very common in everyday life. Usually circuits have more than one load connected together. So if you're filling in notes on your paper there, connected is your first big blank. Okay? So there are lots of different things that are in a circuit. It's not just one circuit for like one light bulb. There are many light bulbs, many plug-ins, many all this sort of thing in outlets in real life. So circuits can be constructed as either series circuits or parallel circuits, or even a combination of the two. So what does this actually look like? Let's get into that here right away. So we have a source here, battery source, power source, and we have a light bulb, okay? And so when we have electrons flowing and current flowing, right, we have a light bulb here is being lit up by the battery. But what else is happening? What's after this? Okay, so there could be a series of different arrangements here for after this. So let's keep going. A series circuit. You go. A series. So here are 3 lamps on the paper here. So you should be on. You have one? Okay, you should be on the second page of your notes here. This is a series circuit. 3 lamps connected in a long chain. Now you have to draw this out because you have a little space here to draw this out. So we have 3 lamps, one here, one here, one here. And they're connected on a long chain from the negative terminal of the battery to the positive terminal of the battery. Now, which way they're connected, that really doesn't matter, but looks like this is the positive end, here's the negative end. So we're going this way. Now, the defining characteristic of a series circuit is that there is only one path for the electrons to flow. Only one path. So you see as the electrons come out from the negative, right? The electrons are coming here. They only have one way to go. Boom. They hit the light, give it some energy, and they go around the path here some more. Boom. Hit this other light, give it some energy. And then these electrons are getting a little tired here by the third light. Boom, they give this a little bit of energy, and then they're finally back to get recharged in the battery. Okay? Finally back here. So one path for the electrons to flow. This says draw a circuit diagram for the above image. Use small arrows on the outside of the drawing to show the direction of electron flow and larger arrows on the inside. So a circuit diagram, you want to go back to your let's see, to your circuit. Where was it? That's here we go. The circuit diagram stuff. So that diagram that you drew with the battery and with the light bulbs, please use these symbols. Here's a battery, or here's a cell, and here's a lamp. Okay? So draw that in your notes there. Yes. So your diagram should look something like this. Here's the electron flow. Okay, going this way, from the negative to the positive terminal. That's the electron flow. Okay, electrons. And little symbols of electrons, E with a little negative as an exponent there. That's the way you'll commonly see electrons represented. Okay, any questions about that one? So it says use small arrows on the outside of the drawing to show the direction of electron flow and larger arrows on the inside to show the direction of current flow. So current flow is opposite of electron flow, right? So remember, you can think of it this way, as the electrons jump from one kind of atom to the other and go along, the positive charge almost like jumps the opposite way to fill in that spot that it left. So think about that. So the current is going from the positive through this way. Okay, the actual, whoops. So from the positive to the negative. So electron flow, and then this is current flow. And how you can remember that if you're still struggling with remembering that, because it is a little confusing, right? But on the negative terminal, see it's negative. That's where the electrons hang out. They love hanging out on the like the negative terminal because they're negative. So it's kind of like their party hangout there. That's their group, their little club. And so then they go out from there and they want to go and they are attracted to the positive terminal. So they want to get back this way. So they all gather here and then they leave. And then the current, you think about the positive energy, okay? Positive energy's got to be given out to the loads, and that starts at the positive and goes the other way. So it's opposite. However you want to remember that. Okay? Okay, we'll keep moving on. Now we're going to talk about parallel circuits. So series is pretty easy. Parallel circuits is a bit different here now. Again, there are 3 lamps here in the drawing below, and you're going to start to draw this drawing. I just got a portion of it here for you. You're going to draw the whole thing. But let me explain why this is different or how this is different. 3 lamps, but this time there's more than one path for the electrons to flow from the negative terminal to the positive one. Okay? So you'll see here that there are options here for the electrons to flow. Now, I'm going to help you complete this diagram here. Okay? So this is the negative side. This is the positive side. So electrons are actually coming down here, and they're going this way. Okay? Now, this is what the parallel diagram starts to look like as we complete this. And here's another light bulb, 3rd light bulb. Okay? And so the electrons, when they get here, do you see how they have a choice? There's like a split in the road there. So they could go this way or this way. And they kind of like, some go this way and some go the other way. So electrons kind of have a choice. And remember, there's just trillions and trillions of electrons flying, so they kind of fill both paths, really. Okay? So the defining characteristic of parallel circuits is that there's more than one path for electrons to flow. Each of these paths is called a branch, like a tree, okay, a branch. So yeah, so these electrons, they're going here and they're passing by this light bulb, giving off some energy here. Some of the other ones are going down here. Oh, these ones are flooding this path and this path as well. So they go along here, give some energy over here and so on, and this is what's happening. They're taking all available paths here back to the positive terminal. And they join back up here on the other side, you see? They join back up here. And then they get back to the positive. So instead of everybody going down one path and shoving through one path, they split up. And so they can hit all these light bulbs now. So there are some advantages to parallel circuits, for sure. There are some big advantages. Now, go ahead and draw the circuit diagram here, so get some practice. Remember how we draw our battery. Positive, negative terminal. Okay. And basically it's the same as the last one. So we're going to come from the negative, right? The electrons are going to flow down here. They're going to go over here. And some of them are going to go up here, and some of them are going to keep going. Up here we have a lamp. Remember how we draw that? Kind of this funny little symbol there. And that's sort of one little path that the electrons can take, okay? The other path here, along here, okay, so you're drawing just what I'm drawing here.
Just kind of redrawing it.
Well, you're using the same symbols and you're drawing the parallel, what the parallel circuit looks like. Exactly.
Oh, I thought we were supposed to draw it on the top image.
So, yeah, just up here they drew the battery and the light bulbs. This is the circuit diagram. Yeah, same thing. So electron flow here, right? We've got the arrows there, electron flow, so on, and the other paths as well. And then the current flow is the other way, right? And that goes here, goes there. So it kind of goes the opposite way. Oops. So what's the big advantage or disadvantages of these types? Well, sometimes these parallel circuits can get a little complicated to hook up. Maybe a series circuit in series is really simple. It's really simple. You know exactly where the electrons are moving to and what they're passing through. Yep.
For parallel circuit, isn't it also easier to weaken it? Wires?
Well, okay, so that's good. That's a good question. Is it easier for there to be a leak? Now, when you say a leak in it, you probably mean like a short or somewhere for an alternate path for the electricity to escape from. Yeah, there could be more wires and stuff involved for sure. But let me talk to you about what's really an advantage here. So series. Now, remember with this pathway right here, so all of these electrons, there's a whole group of them here, big group. And as they pass by this light bulb, some of them jump off here and really give their energy away to this light bulb. And so they have a little bit less energy here. As they get to this light bulb, they give off some more energy. And now they have even less energy as they continue through. And when they get to this light bulb, they don't have much energy left at all. They're just so weak. And by the time they get back here, they really need to be recharged here. So in a series like this, all of these light bulbs will be a little bit dimmer. They won't be able to get as much energy because it's just one path for all these electrons to go through. So as you keep adding more light bulbs, all the bulbs get dimmer. Okay? Now the other thing is, if we had some kind of breakage or leakage or a shorting out of something like this, then all of the lights at once would go out. All of the lights would go off. And sometimes if you have like Christmas tree, okay? So if you have a Christmas tree and you have a, nice Christmas tree kind of like this, and you've got lights, okay? You've got lights going back and forth in your Christmas tree, and everything is just honky-dory. Have you ever heard that term before? Honky-dory? I'm old, so when I was a kid, that was kind of a term for that means everything's going just great. It's going just honky-dory. And then all of a sudden, boom, your tree is completely dark.
And it's on.
No, it's not on fire. No, it's not on fire.
Sure.
It's completely out. All the bulbs are out. Like, all the bulbs are out. And you know what happened is this particular setup, if that happens, all these bulbs are in series, and maybe one bulb has broken or one bulb something's happened to it. So if one bulb in a series circuit gets interrupted, then all of these electrons here, boom, they don't get past that. They're stopped. Okay, they stop here. And then these ones they all go out. Now, with a parallel circuit, okay, and the reason why this is pretty cool is because let's say that we have a bunch of electrons here and they're going here, and there's so many of them, some of them split here, some of them split here, it's about half and half, and it's about the same. So these guys light up this light bulb, they take a little bit of energy down and then they go back to the battery. Well, these ones are still full force, boom, full force, awesome. They give a little bit of energy away and they have to go back and get recharged. These guys here, still full force, boom, give some energy away. So in a parallel circuit, see, each light bulb is getting really the full force of the electronic charge because there's so many of them and they kind of split up. And then they all kind of come back to the battery to get recharged. And the other thing that's cool is what happens if there is this light bulb bursts right here. Guess what happens? It's just the flow through this. All these other bulbs still get fed. And so if you have a Christmas tree, again, you have a Christmas tree here, okay? And you've got lights that are coming up from the wall outlet, and you've got lights that are strung all the way around the Christmas tree, and you have all these lights are shining, and this is awesome, and you have one light bulb that goes out, then what happens is just one of them goes out.
Oh, I mean, yeah.
They don't all go out.
Yeah,
Parallel. So the broken light bulb, you'll see that it's not shining, but all the other ones are. So you can easily spot and fix the broken one. And you just replace the broken bulb, and boom, It's all back together. But the series one is like they all look dead, and you don't know which one, if it's broken or just a wire has gone in there. So it's really tough. But parallel circuits are really useful this way. Yeah, got some questions.
What's the good thing about?
Well, they're simple. The good thing about series circuits is they're super simple. They're super simple. And sometimes when you don't have a lot of loads, and you know, if it's just a small, simple circuit, that's all you need, series is fine. Yeah.
But when
So the question is why do the electrons always, you know, go around, you know, this direction here, and why don't some of them come back here and get mixed up in here and go this way? Well, because they're being pulled by the positive terminal. So they don't want to come back here, they want to get back to the positive terminal.
they want to recharge.
They want to recharge, you bet. That's the way it goes. Like water in a water hose, right? Like it's, you know, it wants to escape. It doesn't want to kind of back up in the middle of the hose. Yeah. Okay, another question?
But don't the electrons try to like the shortest possible distance?
Well, good question. Don't the electrons want to take the shortest possible difference? Think about it this way. If you're in a corn maze, and you don't know which way is out, and you have two choices, there's no way that you know which way to go. So if there's a group of you, you'll kind of randomly, one will choose left, one will choose right. So they just know that they have to get to the end. They don't know exactly which path to go. So because there's so many of them, they end up filling both paths. They don't really know kind of what's ahead. Because there's similar resistance ahead, I don't know. Yeah, they don't really know. It's a good question. They don't know what the shortest path is. They don't see the end from the beginning. Oh, were you? You were in a corn maze last week? Okay. Very cool. It's that time of year, I guess.
The dinosaur one?
Okay. Everybody. Grade 9s, focus up here again, please. All right. Let's see, the last part here. Series and parallel. So there are circuits that are combinations of both series and parallel circuits. Combinations of both series and parallel circuits. Let me get to my proper notes here. There we go. So series dash parallel. That are combinations of both. So what you're asked to do here is draw a circuit diagram. So using your symbols that has 3 bulbs, but this time, listen carefully, make 2 of the bulbs run in parallel and 1 of the bulbs in series. 2 of the bulbs in parallel, 1 of the bulbs in series. Use small arrows on the outside and so on, large arrows on the inside for direction of flow. Okay, so go ahead and see if you can do that. We've got 3 bulbs. 2 of them are clearly in parallel, and 1 is in series with at least 1 other one there. Okay, go ahead and draw that and see what you come up with. Okay, so your drawing may look something like that, may look a little different. Here's the key. It's probably easier to start with the 2 that are in parallel, right? Those are easy. You know what parallel is. Now, where would you put the 3rd bulb to make it in series? Well, you couldn't make another parallel. You couldn't make another parallel here. That's not in series, so you're not going to do that. But if you put it somewhere, and boy, if you put it here, this would be just 1 bulb that's in series. If you put it over here, then you'd look like you'd have 2 bulbs that would be in series. So I don't know about that. Wouldn't be maybe as good, but this would probably be your best bet. So if the electrons are flowing here, and the black, they're flowing out here, they only have 1 path to choose to get to this light bulb. Only 1 path. Boys, the back? Hi. Here they have a choice, so that means that these 2 bulbs, where the choices are, those 2 bulbs are in parallel. So this one's in series, these 2 over here are in parallel. These are parallel, this is series. Question?
Where I did the 2 parallel.
All right, so please work on this drawing electrical circuits. We've talked about series and parallel here now, so you can do all these questions. We've done number 1 together here, so that's simple. 2 cells lined up together, a motor, which is this one right here, and a voltmeter connected in series, 1 path only. So go ahead and work on the rest of these questions on your worksheet. There's a worksheet you were given last week.
Yeah, but we didn't even know what series were.
I don't think I have it.
And 2 cells is 2 batteries.
So there are some questions about brightness of lamps too. We talked about those, so that's what we're ending with. So, okay, go ahead and work on those.
I don't have that.
Here's some answers to these circuits. The circuit assignment here, I'll get you going here. And we'll talk about the rest next class. That's series and parallel.